random things we kids do, and random things sometimes we do, is that we do this. We take out a book and we just look at it. The sides. What's its length? What's its measurement? What's the exact value of it? How heavy it is? What is it carrying? So sometimes we talk about that and it's like, I wish we knew. So what we do is actually finding out the measurement of that object. But what's measurement? Measurement is defined as determining, meaning you're just getting the answer of an exact value. Value as in we're talking about measurement. So what's the value of this object in different types of measurement, like length, breadth, width, height, depth, whatever. Mass. Yeah, capacity of, if it's a glass of water, you can take it. So we always wonder about that. So we're determining the exact value of an object. But we're taking that object as an unknown fixed physical quantity. So what is that? So an unknown fixed physical quantity is that how do we wonder that the measurement of this? It's what? We don't know. So we're going to say it's unknown in the field of measurement. We don't know its length or whatever. So how do we find it? We're determining the exact value of an unknown fixed physical quantity by comparing it. Comparing in the sense we're using a known fixed physical quantity, meaning we know its measurement, or it's one of the tools that helps you in measurement, like a ruler, like that. And it compares with the object you're measuring to find the answer. So determining the exact value of an object, of an unknown fixed physical quantity with a known, by comparing it with a known fixed physical quantity, is known as measurement. Yeah, it's simple. But there are many types of these physical quantities, like a ruler or a meter rod or a something. And there are many, they fall into different categories, and two of them are fundamental fixed physical quantities and derived fixed physical quantities. We'll get into that right now. So what's a fundamental fixed physical quantity? What does it say? So it means that it's at the very basic, like how a math problem and you just cut the fraction into its lowest terms, it's in its lowest terms. Basic. It doesn't contain anything. It just itself. So it is not derived from anything, like it doesn't need two parts. It's itself and that's one part and that's the whole thing. And that's used for measuring things, and there are 7 of them. There's temperature, time, amount of substance, mole, luminous intensity, there is meter, there's length, there's mass, there's capacity. Boom. There you have it. So they're not derived from anything, right? And they just use some components that are just one whole thing. What's a derived physical quantity? Now that I've said this answer before, you should be very clear with it. It's derived. So it has 2 parts, which can be anything, of a fundamental fixed physical quantity. So a derived fixed physical quantity has parts from the fundamental fixed physical quantity to just make an, I'd say, upgraded version of measurement. Like how do we find speed, density, time, actually not time, speed and density. Like them, we use 2 parts, meter per second in speed and density something. And that's a derived physical quantity. They both are very straightforward. But how did they used to do it in the past? How did they measure things in the past? And that's how we come to the ancient times. In ancient Babylon and Egypt. And they used a very weird kind of measurement. It's stupid. So they use their own body parts. Their own body parts. It's very weird, very stupid. It's just very weird. Don't follow it, kids. But if you're willing to try it, okay. So they are primarily the cubit, handspan, fingers and palm. But what's a cubit? Well, a cubit is basically the measurement. See, it varies from size to size. It can be any. It can be your kids. It can be your moms. It can be your dads. It can be your great grandson. It can be anyone's sizes, just knowing that it's the right measurement on how you measure it. So I'm taking this, my hand and my elbow. So a cubit is basically the measurement from the tip of your elbow to the tip of the middle finger, because that's the highest point. And that's a cubit. So I could say, hey, this shelf is 5 cubits, or 2 cubits for that matter. It can be 10 cubits. Now, what's a handspan? Handspan. So it just determines the length between the thumb, the tip of the thumb, and the tip of the little pinky finger. So it's just this much, like this, yeah. And now we're going to be talking about the palm. It's basically the width of the hand, normal hand. Like how do you walk? Your hands are not outstretched. It's like this. So this is the width of the hand, because it won't change. And after that, we're going to be talking about the finger. The middle finger. The bottom of the middle finger, I guess, like this, to the tip of the middle finger, like this. Okay? That's it. But afterwards, the Greeks, they included the foot. So a foot is, they measured it. So the foot was about, just measured. So from the, I guess, the 2 ends of the foot, those are measured to the highest point of the foot, because it's uneven. Now in medieval times, the most famous was the measurement system of Britain. So they created the foot-pound second, or the FPS system, and in which the foot was 3 barleycorns long, and it was 12 inches. Like I said, they use their body parts, but I didn't say that they use their surroundings. Barleycorns. But they were specimens of the foot was the unit of length, the pound was the unit of mass, and second was the unit of time. And that's not confirmed, because it was the medieval times, but at least they tried. Now we come to the need of standardizing units, and people were like, why are we still here? Just to suffer. Yes, they had to suffer in their own arguments, because it varied from size to size, like I said, and it could say, like a kid could say, hey, this shelf is 5 cubit, and an adult would say, no, it's 2 cubit, because, and someone would say, hey, this is 3 feet, and one would say, what, this is 1 foot. So they needed to standardize these units because they varied. And that's all. So in 1791, the French Academy of Sciences, they made a simple system, but also scientific. Yes. Weird. Okay. So it was the metric system, where length was included as the unit of length was meter. And of course, the unit of, let me get on with it. So it was divided into 2 parts, and it was the CGS and the MKS system. I was like, I'm right. No, he's right. No, she's right. No, the MKS system and CGS system were very different, but on the same path, I guess. So the MKS system, I guess CGS system actually. So the CGS system contained a centimeter, which was the unit of length. The CGS, what was it? Gram, sorry. Gram was the unit of pound, mass, and the second was the unit of time, so also following the British pattern. But the MKS system is what we kind of use today. So the MKS system had 2 right and 1 wrong. M and K and S was wrong. You know why? MKS system contained of meter, which was the unit of length. kg in the unit of mass. And the wrong one, second is wrong. That's the unit of time, which is not, it's minute. And these two, they were used by users, and they had to be interconversion between the users, because it was used by maybe America followed the MKS system, but the CGS system was followed by the Indians. It could be that, and there had to be interconversion, like how there's interconversion between rupees and dollars. Yeah, it was like that. Doesn't really fit with oil and water, really. It's like oil and water. And this is where the General Conference of Weights and Measures, they came in clutch and met in Paris and adopted the International System of Units, or the SI system. And this included what we know today. We follow the SI system, all of us. SI system, International System. And what is it called in French? Des International de Unites. The Système International de Unites. That's what they said in their fancy French way. Yeah. And this is what we know today. But what are submultiples and multiples? Now, sometimes the normal measurement of the SI system, like in the SI system, meter was length, kg was second, mass, and finally minute or hour. Minute came in time. But they couldn't be used in some pattern, so submultiples and multiples were introduced. Yeah, so sometimes meter is not enough to measure the distance, not big enough to measure the distance between two cities, because, well, it's big and hideous, and it's just messy. It's just, yeah, it'll take a long time. But kilometers, it's a multiple of it. It'll take less time. Centimeters was used to measure like a thin wire, or a millimeter actually. So like that, there were multiples and submultiples, and we all know that meter is centimeters and decimeters and millimeters, and then above of that there's meters, and then there's centimeters, there's decameters, there's hectometers, there's kilometers, and there's more. Megameter. And like that, there's also mass, and there's blah, blah, blah. Well, that's actually it for part 1, and I will see you in part 2. So it's just me signing off, and I'll tell you, this is a big chapter, so it might need a part 3. Bye.